first one?
This is for the first one. I'm going to show you how I did it, how I approached it. So the first thing I told you, I just drew a Venn diagram just to see what it looked like. That's what A complement looks like. It's everything outside of A. And B complement is everything outside of B. That's a habit I have as my first. I needed to know where to start. There's a place to start. I've drawn that out just so I can see it. Then I went to the book. I don't have anything memorized. Even whether it's pajama day at school for my kids, I don't have that memorized. And so they go to school with their regular clothes on. I have nothing memorized. Colonel Hartley will tell you that. And so I always look it up in the book. And in the book, I know that at least I have an inkling that something's in there that has a formula for conditional probability. So I went to the book and I looked up what the definition of conditional probability is. And it's that thing over there. And then I combined common denominators. I don't think that path that I'm taking is not the path that every mind will take, but it's the path I took. I saw some of you going along these lines in a different direction, and I think it will still work. So then I said, okay, what if this was equal to 1? Well, if this is equal to 1, then if I cross multiply, then I should get that. Right? Well, then I looked at this thing over here, and I had my Venn diagram sitting in front of me, and I'm like, wait a minute. The probability of B and the probability of B comp, those are mutually exclusive sets. I had it sitting in front of me. But if they're mutually exclusive sets, then that's the intersection. I saw it symbolically, but someone around here said, and I think you said, that, hey, if they're mutually exclusive, how can that be? You're doing this and that. So they thought out on words. Being in B and not in B at the same time, that's impossible. The probability of that happening is 0, right? You cannot get an A and an F in the same class, right? That's impossible. They're mutually exclusive things. And so that left-hand side, there's a little flaw in my logic here because I'm scratching around because I can't divide by 0, right? But I'm just saying, what does that tell me when I got that thing right here? Right now, what is that telling me? What do I know about probabilities? What range do they have?
Less than 1.
And what else?
0 to 1.
0 to 1, right? So the only way this could be true is if everything was 0. And I can certainly come up with a case where everything's not 0. Got it? So now I know the answer. What's the answer going to be?
False.
It's a false one. You see that? Right? Because I know that no matter, I can put in probability, I can make up an example where this side's not 0, and then I'm done. And so just about anything I can think of will work. So now comes a lazy part of my background. I just said, okay, I'm going to come up with the easiest example I can. And so I just came up with coin flips. I don't want a die that has 6 things in it. So I just want a simple example. I could even come up with just one coin flip and come up with something. Anything will work. So I just took 2 coin flips. I let A's be that heads came up first, B be the set that tails came up second, wrote them out, and then I plugged in the formula, and I already know it's not going to work, right? Because I saw that little equation of the thing. And now these probabilities are not 0, so I know that they're not going to equate up. So I'm done. But that's my explanation up here, because I already did my time. If you're doing your homework, you'd actually have to plug it in and show. Just like the example I gave you with knees to elbows. You have to say, hey, I see that person up there doing knees to elbows. So what you just said is not true. You'd actually have to demo it and show it. All right, are there questions about that?
Can you go back?
Sure.
Regular posters.
Yeah, these are already posted on Blackboard, and I'm recording it and posting on YouTube.
What do we search on YouTube?
I think I gave you the playlist. I just stick about a playlist.
One of the videos doesn't have sound.
I know, I think I had it on mute initially, but it's not on mute now.
When I see the solution, it's like, oh,
Yeah, because
myself.
I was thinking, watching you guys, one of my feelings as a teacher is I don't like to see students struggle, which is probably why I'm not in DPE. But I see you guys struggle for a bit, and I think holding myself back from giving you the answer. I think, but then as I was watching you guys struggle, I thought, well, I struggled with it in the office. You just didn't see me. But no one was bothering me this morning, and that doesn't count death. No one came in with forms that I had to fill in, and so I was alone there in the morning, and I sat there. The difference is I enjoy sitting maybe and doing this and thinking about it, and so I didn't think of the time going by. I relished doing these kind of problems, and so. But I struggled. I didn't get the answer right away. I didn't know which ones were true or false. I just fooled around with it until I got to it. I think that as a mathematician, we get comfortable with the idea of fooling around with it and extremely confident that we can get the answer. That's why people work on open problems for their entire lives. I have an open problem I've been working on for over 15 years. I'm not confident anymore I can solve it. But once in a while, I have the audacity to sit down and think I can think about this again. So we get really confident. So that ability to sit there and think about something for a long period of time. So you start with these kind of classes as an undergrad. If you go to graduate school, you learn that, hey, I have the ability to sit and think and put my mind to something and really figure this out.
So where do you get these open-ended problems?
There's some of them that are just out there that people have been struggling with for centuries, and there's some of them that you look at and you puzzle over and go, I wonder if this is true. I think this is true. Can I prove that it's true? And I start working on it, and then a few years later I look at it again and think, I don't think I was smart enough back then. I'm going to try it again in a different angle. So, yeah.
But man, what's the problem?
You don't want to know that. It actually takes a little while to explain it. But okay, so go to the second one. And the third one, you don't have to use the same approach I did. You're just fooling around with it, trying to figure out whether this thing is true or not.